Hi there, it's Professor Monte, and let's look at a work application having to do with quadratics. Okay, I wrote down the three keys to get us started. One is rate times time equals the amount of work done. And it looks very similar to rate times time equals distance, but for work problems, we can use rate times time equals work, and I'll show you how that works out. The other key is rate equals 1 over the total time to get the job done. So for instance, if the total time for something is 3 hours, that rate is going to be 1 over 3. And you can think of it as, oh, if they can get the job done in 3 hours, every hour they get 1/3 of the job done. Or it's one job every 3 hours. Okay? So the rate is 1 over its total time. And then the total work, they're going to get one job done. So let's see how this works in an application. Two pipes working together can fill a pool in 4 hours. The larger pipe working alone can fill the pool in 6 hours less than the smaller pipe alone. How long would it take the larger pipe working alone to fill the pool? So we've got a few things going on here. Let's name our variable. So it says the larger pipe alone can fill the pool in 6 hours less than the smaller pipe. So it's telling us the time for the larger in terms of the smaller. So the smaller is going to be x. So I'm going to say let x equal time smaller pipe. Because if the larger pipe can do it in 6 hours less, that's going to be x minus 6 time larger pipe. Okay, now I'm going to use my formula. Rate times time equals work. Rate times time equals work. I'm going to set up my boxes. Rate times time equals work. And we'll put them in this order. I've got the smaller pipe. I've got the larger pipe. All right. We want rate, and remember rate is 1 over its total time. Well, if the total time for the smaller pipe is x, then it can get every hour it gets 1 over x of the job done. One job every x hours. The larger pipe is going to be one job every x minus 6 hours. Okay, so both times I'm just using the idea that the rate is 1 over the total time for whatever that is. Now, working together, they can fill the pool in 4 hours. So if the smaller pipe works for 4 hours and the larger pipe works for 4 hours, they get the job done. Well, every time I set up these boxes, whether it's rate times time equals distance or rate times time equals work, you're always going to have one of the columns is usually just going to be numbers from the problem. One of them is going to be variables from the problem, and the other column is going to come from the formula. Well, this time, work is the blank one, rate times time equals work, so I'm just going to multiply these two together to get that. And remember, this is just 4 over 1, so when I multiply across, 1 times 4 is 4, x times 1 is x. The amount of work that the smaller pipe gets done is 4 over x. Similarly, this one's going to be 4 over x minus 6. Okay, I've got the box filled out. I still need my equation. Well, what did they tell us? Up here, when I talk about the total work is one job, that's what I'm using. So I'm going to say the work from the smaller pipe plus the work from the larger pipe equals one job. That's the idea. Well, work comes straight from there. So I say, oh, 4 over x plus 4 over x minus 6 equals one job. Boom, I have my equation. So the equation comes out pretty easily once we remember this and once we set up our box. So now I'm just going to solve this. So I'm going to multiply through both sides by the LCD. Now remember, the LCD can't be x minus 6 alone because these x's can't cancel because you have a plus or minus right here. But if I do x times x minus 6, that's the LCD. I'm distributing that in over here, so this gets one of these also. And this gets one of these also. All right, so here the x's cancel, here the x minus 6's cancel. And so I distribute here, 4x minus 24. Plus, those cancel, is just 4x. Distribute again, x squared minus 6x. Now, this is one of those problems. I have an x squared and I have an x. I'm going to need to set it equal to 0 to either factor or use the quadratic formula. If I only had x squareds and no x's, I could just isolate the nth word and take the square root, but that's not the case. So combining like terms here, that's 8x. So I get 8x minus 24 equals x squared minus 6x. I need to get it set equal to 0. I'll subtract the 8x and add the 24. So I get 0 equals x squared minus 14x plus 24. Try to factor that. If you can't factor, if you don't know how, use the quadratic formula. But this factors, I need two numbers that multiply to positive 24, add to negative 14, negative 2 and negative 12. X minus 2, x minus 12. It's a weird looking 12. That's better. And so set each of these equals 0. X minus 2 equals 0, so x equals 2. X minus 12 equals 0, so x equals 12. Now notice I get two answers. But let's go back up here. X is the smaller pipe. We'll put it here to remind us. X is smaller. X minus 6 is larger. Well, if I put 2 in here, I'm going to get a 2 there and a 2 minus 6, which is negative 4 here. I hate to tell you, but it's impossible to fill up the pipe in negative 4 hours. That one can't work. So this can't work. So actually the 12 is going to work. If I plug in x is 12 hours, and then x minus 6 is 12 minus 6 is 6 hours, that's my answer. So the smaller pipe can do it in 12 hours, and the larger pipe can do it in 6 hours. And remember, the question just said, how long does it take the larger pipe working alone to fill the pool? Oh, the larger pipe can fill the pool in 6 hours. So practice these. They take a little bit of work, but remember these three key ideas. I love using the chart, the little table here. I think that helps me a lot. So I think if you get used to using that, it'll help you a lot too. But practice, as you know, the more you practice, the better you'll get. And as you do more of these, they seem easier and easier. All right. Hang with it. Don't get discouraged, because you can do this.